students, welcome back to our channel Diksha Karnataka. So as you know, your COMEDK is approaching and we have started a series where we are discussing the top 30 questions from all the important chapters. So in today's video, we'll be discussing the top 30 questions from the chapter Organic Compounds Containing Nitrogen, or that is your amines chapter, right? So this is a very high weightage topic and you can easily expect 3 to 5 questions from this chapter. So if you are able to, so most of the questions here are from previous year papers. So if you are able to solve these questions and you can also practice similar questions, you can assure that this chapter is ready for your COMEDK examination. Okay. So we have covered like all the different concepts from this chapter. So do practice such questions, and you can also do like you will get an idea what type of questions from this chapter are asked in the COMEDK examination, right? So let us start with the first question. So the first question is, in the following reaction, the structure of the major product is. So we can draw the structure once again. So we have here phenyl ring, and then you have NH, okay, and then C double bond O, and then again one more phenyl ring. And we are giving it with concentrated nitric acid and concentrated sulfuric acid. So if you know, these two are the reagents for nitration, right? So now what happens, if you see this one, I'll do the pH, I'll open the circle and do it once again. So you know this one, NH group is a ortho-para directing group. Its reactivity has been reduced by adding this group. Now what happens? The incoming nitro group will go to the para position of this one, right? So it is a electron donating group. So we know it is ortho-para directing. So we will get the compound here, nitro group, okay? And then we have this side NH, C double bond O, and pH. Okay, so you can see at the para position the NO2 group is attached. So the correct answer for this question will be option number B. Okay, you can see here also option number B. You can see that the para position the NO2 group is attached. Okay, now let us see the next question. The main reduction product of the following compound with NaBH4 in methanol is. So NaBH4 is a reducing agent, okay? It can reduce only aldehydes and ketones, right? So now if you see here, this is an amide group, right? So this is an amide group and this one is a ketone group, right? So ketone group will be reduced and we will get OH in presence of that. So if you see option number 1, in option number 1 double bond is reduced, that is not correct. In option number B, this double bond O is reduced to OH. That is what will happen in the presence of NaBH4. So correct answer is option number B. Okay. Hello students, Diksha and Vedantu has launched a COMEDK 2024 mock test series in collaboration. So in this series, you will be getting 10 mock tests. So there will be 8 full-length mock tests and 2 part test mock tests. Now what are the features? You can see there will be 8 full tests and 2 part tests, and this will be exactly in the COMEDK exam pattern. Next, all the exams will be in the CBT mode, and then you have the freedom to retake the test multiple times. Okay, you can write the test multiple times, and then you have like all the questions are in the latter syllabus of COMEDK, so deleted topics will not be there, and you will get a comprehensive analysis report after each test once you submit the mock test. Okay. So this mock test series is available at the price of 499 rupees. So please join it, enroll it, and the link is there in the description section. Now let us see the next question. Aniline can be prepared by. So what is the structure of aniline? You see aniline has NH2 structure, right? Now the degradation of benzamide with bromine in alkaline solution, reduction of nitrobenzene. So if we have this one, benzamide, okay, and with this one you treat it with bromine in alkaline medium, right? So we can have KOH or NOH. Yeah, so this one, you know, this is Hoffman bromamide degradation. So from here we can get benzene with NH2 group. So that is your aniline. So correct answer for this question will be option number A. Okay. Next question. Which of the following, which is the decreasing order of basicity of primary, secondary and tertiary ethyl amines and NH3? So now what are the values given here? You can see primary. So primary amine is this one. Primary, secondary and tertiary ethyl amine. So this is primary ethyl amine. Okay. Now if I want to make secondary ethyl amine, so it will be CH2, CH3, and we have here CH2, CH3, and then tertiary ethyl amine, it is CH2, CH3, CH2, CH3, and we have CH2, CH3. Okay. Now, if you see, if it is not mentioned whether it is gaseous medium or it is aqueous medium, but generally the question is like asked from your aqueous medium. Okay, so now if we see, since the question hasn't mentioned anything, if it is gaseous medium, then the answer has to be option number B. Okay, but in the previous, this is a previous year paper for the, but the question was according, the option was according to your aqueous medium. So if we see aqueous medium, in that the degree will be, the order will be 2 degree, 3 degree, 1 degree, and then NH3. Okay, so you can see 2 degree, 3 degree, 1 degree, and then NH3. So answer can be D if it is mentioned aqueous medium, and if it is not mentioned, then in the gaseous medium, answer can be option number B. Okay, so you have to read the question carefully and then solve this question. Next one, among the following amines, the strongest bronze state base is. So base is the one which can donate your lone pair, okay, or accept H plus, right? That is the definition of this one. Now, if you see in the first one, in aniline, what happens? The lone pair of the nitrogen is not available for donation because it is in resonance. Okay, that is why this nitrogen cannot even accept the H plus, because its lone pair is involved in resonance with the ring. Now, if we see here, this lone pair is involved in resonance, and it is because it makes the compound aromatic. So this is also not basic. Now, if you see here N, okay, this lone pair is available for donation, and this lone pair is also available for donation. But now, if you see here, the side groups are H, which doesn't have any effect, but here there is alkyl groups which can have plus I effect and increase the electron density, as a result of which the basicity will increase. So the correct answer for this question will be option number D. So what is the reason here? The electron density on nitrogen increases due to the plus I effect of the groups, plus I effect of alkyl groups. Okay, now let us see the next question. Amongst the given set of reactants, the most appropriate for preparing the secondary amines are. So secondary amine structures, if you know, it is like N, H, R, and R. Okay. Now, if you see secondary, we have any amine, and then we are and we replace it with bromine and NH3. So we will not get in that one, right? Secondary R, this is not like you have this. This is the product. Like this is given. So here bromine will be replaced with NH2. So that is again a primary amine. Now, if you see this one, like secondary alkyl halide, okay, secondary alkyl halide, and you treat it with NaCN. So we will get here again. If I erase this one, NaCN will give you CN. Okay, and then when you hydrolyze it or we treat it with H2 palladium, we'll get CH2NH2, which is again a primary amine. Now you see this one, a primary amine, that is RNH2, okay, and treated with RCHO. So we can write like this, sorry, RCHO. So we will have CH and R. Okay, now what will happen? This H2O will be removed. Now what we will get in this condition? R, N, double bond C, H and R. So if you have remembered, these reactions we have studied in the addition of ammonia and its derivatives, nucleophilic addition to aldehydes and ketones. Now what happens? Now when you treat it with hydrogen and palladium, H will be added to both, and we will get R, NH, CH, H and R. Right? So on the end we have one hydrogen and two R groups. So this is a secondary amine. So the correct answer for this question will be option number C. Okay. Now let us see the next question. In the given sequence of reaction, okay, so 2-bromopropane is there. Okay, we have 2-bromopropane, and then we are treating it with AgCN. So we will get NC here, right? If KCN is there, then it will be CN addition. If AgCN is there, then it will add NC, right? Now if you have your LiLH4, so it will reduce this one. We will get here NH and here CH3. So now this is what N-methyl and propanamine, propane 2-amine, right? At the second position, the amine group is present. So N-methyl propane 2-amine. N-isopropyl methanamine is also correct, but that is not the IUPAC name, right? Isopropyl is a common name. So the correct answer for this question will be option number B. Now let us see the next question. Which one of the following is a secondary amine? So for secondary amine, what is the structure? We have R and R. Okay, this is secondary amine. So we have the option, you can see N-methyl 2-pentanamine. If I draw this one, we have N-methyl pentane 2. Okay, N-methyl pentane 2 amine. So the correct answer for this question will be option number C. Next, during ammonolysis, primary amines act as. So if you see this one, what happens when you first treat Rx, okay, with NH3, then what we get? The first product here formed will get R NH2 plus HX, right? What happens? One X and one H goes out and NH2 and R will combine. Now again, when you react this one with Rx, okay, so the question is during ammonolysis, so again when it is reacting with this one, one HX, one H and one X will go and we will get R2NH, right? So the question is asking during ammonolysis, the primary amines behave as. So they are behaving as a nucleophile, right? So the correct answer for this question will be option number A. Okay, next question. Hofmann-Bromide reaction is used to convert. So we know if we have RCONH2, okay, and if we have any Br2 in alkaline medium, that will replace or remove this CO and we will get RNH2, right? So the correct answer for this question is from amide to amine. This is an amide group and the product formed is an amine group. So the correct answer for this question will be option number B. Next, which one of the following gives a yellow oily liquid with nitrous acid? So if you remember, secondary amines, okay, secondary amines both aliphatic and aromatic, okay. What they do when they react with nitrous acid, that is your HNO2, okay, they give you oily compound, okay? A yellow oily compound is formed, okay. So now if you see this one, methyl aniline, we have, so which one of the following is, we have to find the secondary compound, secondary amines in this compound, right? Methyl aniline, if I draw, it is N-methyl aniline. This is a secondary one. Aniline is a primary one, right? So this one will not show. Now if you have dimethyl aniline, so that is again a tertiary one. So we have here dimethyl aniline, and then if you have trimethylamine, trimethylamine is also a tertiary one. So secondary one is your option number A. So the correct answer for this one will be option number A. Next, towards electrophilic substitution, the most reactive will be. See, if we want to do electrophilic substitution, the reactant must be nucleophilic, right? So in which of the following options the reactant is more nucleophilic, that will react faster. Now how to know whether the compound is nucleophilic or not? So if we have any electron donating group which can increase the electron density in the ring, then we can say that this ring is more nucleophilic and it will react faster with the electrophilic substitution. Now if you see aniline, so aniline is this one and it is an electron donating group, it will increase the ring density, so it will be more reactive. Now if you see nitrobenzene, nitro group is an electron withdrawing group, it reduces the electron density of the ring, so this will decrease the reactivity. Aniline hydrochloride, okay, then same thing, and N-acetyl aniline is also N-acetyl aniline if you do. So we have this one, here it is replaced with COCH3 group, right? So here also compared to aniline, here what happens, the lone pair is distributed on both sides, right? So the donation here will be less as compared to pure aniline. So the correct answer for this question will be option number B. Now if you have in NCl is there, so right, this one is in this one, if we have replaced with chlorine, that is also a electron withdrawing group, it will pull the electrons from the ring, okay. Next, which one of the following is a tertiary amine? So for tertiary amine, we should have N with 3 R groups, okay. Now if you see 1-methyl cyclohexylamine, so 1-methyl cyclohexylamine, so on one side we have this one and other side we have cyclohexyl and amine. So this is not a secondary amine. Triethylamine, so triethylamine is CH2CH3, CH2CH3, and we have CH2, CH3. Okay. So triethylamine is a tertiary one. So correct answer for this question will be option number B. Next, the best reagent for converting 2-phenyl propanamide into 2-phenyl propanamine. So if you see here, 2-phenyl, so we have here propanamide. Okay, so sorry, one second. So this is the structure. We have here 2-phenyl propanamide to 2-propyl propanamine. Okay, the number of carbons has not decreased, so we cannot use Hofmann bromamide degradation here. So be little careful that one. Okay, now if you see here, this CO group is reduced to CH2 group. So that is done with the presence of LiLH4 in ether. So correct answer for this question will be option number D. So lithium aluminium hydride can reduce the amide group also, right? Okay, next, the correct order of basic nature is. So again, basicity we have lot of questions. The compounds given are your CH3NH2, C6H5NH2 and NH3. Okay, now if you see, NH2 is having this lone pair which has to be donated. So if any group is there which can increase the electron density, then the basicity will decrease, basicity will increase, and if any group is there which can withdraw this electron density and reduce the electron density in the nitrogen, then basicity will decrease. Now you see CH3 group, it has plus I effect. It will donate electrons to the nitrogen, so the electron density on nitrogen will increase, so basicity will increase. Now in this one, C6H5 is the electron withdrawing group. It will take away the electrons of nitrogen towards itself. Now if it takes away the electron, then the electron density on nitrogen will decrease. It doesn't have much availability of electrons to donate. So basicity will decrease here. Here increase, here decrease. Here hydrogen has like no, it doesn't donate or it doesn't donate or doesn't withdraw. So that is why it is a neutral, we can say, and that is why here the basicity will not decrease or increase. So if we compare the order now, first will be CH3NH2, then will be NH3, and then will be C6H5NH2. So correct answer is option number C. Next, a mixture of methylamine and dimethylamine is given to you. So one is your primary amine and another is your secondary amine. The reagents used to separate the components of the mixture are. Okay, so if you know here, we can use Hinsberg reagent and carbylamine test. Okay, so both the options are given here. C6H5SO2Cl and KOH, this is your Hinsberg reagent. In this, the primary amines will react and the product is soluble, whereas the secondary amines will react but the product is insoluble. Now this one can also react with your carbylamine test, where the primary amines will give you isocyanate. So both B and D can be the answer. Okay. Now so let us see the next question. Gabriel phthalimide synthesis is used for the preparation of. So this is very important question. We can only synthesize primary amines from Gabriel phthalimide synthesis. So the correct answer is option number C. Okay. So I'll also recommend here you must know the mechanism of Gabriel phthalimide synthesis. Okay. Next question here is the correct order, the correct increasing order of basic strength of following amines C2H5NH2. Okay. So C2. So this is there. Then we have NH3. Okay. Then we have C2H5NH. Okay. So this is there. Okay. And then we have C6H5NH2. C6H5NH2. Now if you see the structure, you can see here that here there is 2 plus I effect. The donation will be more, electron density will increase. So this one will have the highest basicity. So this option, right? This one will be the highest one. So we can eliminate these two options. Okay, sorry, highest one, right? 1 second. So where this one is given in the highest, so only one option is there where this diethylamine is having the highest value, so that will come first. Then you see here only one group is there but it will donate electrons, so here also the electron density will increase, so that is why this one will come next, right? I hope this is clear. Next one is your NH3 because it is neutral. Here what happens, the benzene ring takes away the electron from the nitrogen and that is why donation will become difficult or less electrons are available. So that is why here what will happen, the last will be C6H5NH2. Okay, so the correct answer for this question will be option number C. Okay, so least, then NH3, then ethylamine, then diethylamine. Okay, next, the major product formed when alkyl iodide is treated with excess of ammonia. So when you treat this one ammonolysis, we get primary, secondary, tertiary and quaternary products. But the question has asked about the major products. So primary amines are the major products. So answer is option number A. Okay, next, on hydrolysis of a compound, two compounds are obtained. One of which on treatment with sodium nitrite, okay, and hydrochloric acid gives a product which does not respond to iodoform test. So if the second one reduces the Tollens reagent and Fellings reagent, the compound is. Okay, let us see the first option. So if we have CH3, CH2 and CH2, then NC. Okay, so now if you do hydrolysis, what will get the product here? Product here will be CH3, CH2, CH2, NH2 plus this one will get converted to acid, HCOOH, right? Now here, when this one, the next question is when this one is treated with nitric acid. So we know aliphatic amines on treatment with nitric acid will give you OH. So CH3, CH2, CH2, OH. So for this one, it doesn't react with iodoform test, because for iodoform test, we need the condition CH3, CH, OH should be present. Right? That is not present here. So this one will not show iodoform test. And formic acid, you know, can react with both Tollens reagent and Fellings reagent. So that is why the correct answer for this question will be option number A. Okay. Now let us see the next question. Some reactions of amines are given. Which one is not correct? Okay, the first reaction is the reaction of a, okay, so we have this reaction that is, I think this is the wrong one. We have NCH3CH3 plus NaNO2HCl, that is nitric acid, right? So when the tertiary amines react with nitric acid, they that is a addition electrophilic substitution reaction of nitroso group. So in this case, the product formed will be the same reactant is present here. In this one, this N double bond O is added, that is the nitroso group is added. But here the product is given different, so this is the incorrect one. So correct answer is option number A. Here you see it can be correct. Primary amines on reaction with nitric acid will give you alcohols. Then this one is your Hinsberg reagent, this is also correct. And this one is your, yeah, this one you can see when secondary amines react with nitric acid, they give you nitroso compound, right? So the correct answer for this question will be option number A. Next, maximum number of molecules of methyl iodide that can react with one molecule of methyl amine. So if we have methyl amine, okay, now how many molecules of methyl iodide can react with this one? So 2 hydrogens will replace, it can react 2 molecules, and 1 the lone pair will react, right? So total 3. So the correct answer for this question will be option number B. Now let us see the next question. The amine which will liberate nitrogen with nitrous acid. Okay, so we know the primary amines, okay, react with nitric acid, HNO2. Yeah, so react with nitric acid. React with nitric acid to give you alcohols plus N2 gas, right? So now you can see which is your primary amine. So the question which will not give, which will not liberate. So primary amines will liberate, other will not liberate. So this is primary, dimethylamine is secondary, 2-aminopropane is also primary. So correct answer for this question is option number C. Now next, phenyl isocyanide is formed when chloroform is treated with alcoholic potassium hydroxide, and so we need to form phenyl isocyanide, okay, and the reagent here given is chloroform, okay, chloroform and alcoholic KOH. So this is your carbylamine test. So we should have a primary amines. So that should be your NH2, right? So the correct answer for this question will be aniline, that is option number B. Now let us see the next question. An organic compound C3H9N, okay, A is there, formula is C3H9N, when treated with nitrous acid, so when this one is treated with nitrous acid, what happens? Gave an alcohol and N2 gas was evolved. So there is one alcohol was removed plus N2. So what does this suggest? When you treat nitric acid and you are getting alcohol, so that must be a primary amine, right? So what does the hint here is? This amine must be a primary amine. Now A on warming, so this is an alcohol. A on warming with CHCl3 and caustic potash. Okay, so this one A. So A on warming with CHCl3 and KOH, okay, gave C. Okay, so this one, if you remember carbalamine test, so this one must be a isocyanide. Okay, which on reduction gave a isopropyl methylamine. So this one on reduction is giving you, isopropyl methylamine. Okay, now predict the structure of A. So again you can check it with options. So very clear. So when you are getting a carbyl amine, you are getting NC. Okay, so this one has to be a primary amine first of all. Now if you see this compound isopropyl amine methyl is formed, means the R group of the amine group must be a isopropyl methylamine, or it should have a isopropyl group. So if I see this one CH3, okay, CH3 is NH2. If this is my A, this will satisfy most of the conditions, I hope. So when you treat it with nitric acid, so this one will get converted to CH3 CH2OH, right? When you treat it with nitric acid, we will get CH3 whole 2 CHOH, right? This is the first thing. Next is when you treat it with this isocyanate group. So what will happen? We'll get CH3 whole 3 CNC. Okay. Now when you reduce it, okay, on reduction, what will happen? CH3 whole 3 CNH CH3, right? So now this is your isopropyl methylamine. So the correct answer for this question will be option number A. Now next question, nitrobenzene on heating with concentrated nitric acid and concentrated sulfuric acid. So you have nitrobenzene and you are treating it with concentrated nitric acid and concentrated sulfuric acid. So in that case, what will happen? Nitration will take place, but nitro is a meta-directing group. So the nitro group will be added at the meta position. So if you see this one, we will get NO2 here and NO2 here. Okay. So the correct answer for this question will be 1,3-dinitrobenzene. That is option number A. Now let us see the next question. Acetamide is treated with following reagents separately. Which one will give you methylamine? So acetamide, you know, CH3CO NH2, and the product is methanamine, that is CH3NH2. So you can very clearly see this CO group is removed. So that is your Hoffman bromamide degradation. For that the reagent is Br2 in alkaline medium. So NaOH Br2 will give you. So correct answer is option number A. Okay, next, which one of the following on reduction with LiLH4 hydride yields a secondary amine? Okay, so we need which one of the following on reduction with LiLH4 yields a secondary amine. So for that we need a isocyanate group. Okay, isocyanate group will give you secondary amine. So methyl cyanide will give you primary amines, nitroethane will not give you. Methyl isocyanate on reduction with lithium aluminum hydride will give you. So we have, if we have this one, CH3N triple bond C, when you treat it with lithium aluminum hydride, okay, we will get CH3NH CH3. Okay, so the correct answer for this question will be option number C. Next, which one of the following is more basic than aniline? So aniline, if we have some electron donating group, it will which of the following is more basic than aniline? So we have to compare. So if we have diphenylamine, right? So option A is diphenylamine. Now if you see in aniline, there is only one one benzene ring. Here there are two benzene rings, so more electron withdrawing power is more, so the electron density will be less. So this one will be less basic than aniline. So this one cannot be the answer. Triphenyl also will be further less basic, so this one will also be wrong. Para-nitroaniline, if you see, nitro is an electron withdrawing group, so it will also reduce the electron density, so this one is also not possible. But if you have benzyl amine, that is your CH2NH2, right? Here the lone pair of nitrogen is not in resonance, so it is purely available for donation. Its basicity will be definitely more than the aniline, where if you see in aniline, what happens? If you see in aniline, this nitrogen lone pair is used in resonance, so it is less available. But here if you see, this lone pair is completely available because it is not involved in any kind of resonance, so that one will be more basic. So correct answer is option number D. Next, how many isomers of molecular formula C3H9N, okay, will liberate N2 gas on treatment with nitric acid? So the question is quite indirect, so you have to just tell me, like you have to just tell here. So if it is giving you nitrogen gas with nitric acid, then what should be the degree of this amine? It should be a primary amine, right? So primary amine, how many we can prepare from this formula? So if I see CH3 means we can have, one is propanamine, okay, and next we can have is isopropylamine. Okay, so in this case, these both are primary amines and they both will give you alcohol and nitric acid, and alcohol and N2 gas and with treatment with nitric acid. So the number of isomers possible is 2. So correct answer is option number C. Okay. Okay, so these were the top 30 questions from the chapter amines, or you can say organic compounds containing nitrogen. It is a high weightage topic and a very small topic. Important reactions you can remember. Focus on Hofmann bromamide degradation and the reactions of isocyanide, cyanide. These are more important. So just prepare these questions, and you like similar questions you can practice. Then definitely you will be able to solve the questions in the exam for your COMEDK. Okay. So if you have found this video helpful, please like, share and subscribe our channel. All the very best for your exam. Thank you.